Assalamualaikum and good morning. For today, week number 4, you will be doing lab module number 3, titled PIC input and output interfacing. So for this module, you're going to concentrate on interfacing with 7 segment and also a keypad. So keypad for this laboratory session, I will be explaining some of the basic part, and then next week, on Monday, I will continue with chapter related to keypad. So right now, I will concentrate on the important aspects such as programming and the setting part for keypad and also 7 segment. But the 7 segment we have covered on Monday. So basically, just a brief explanation related to this topic. So we look at the objective first. There are 2 objectives. The first one, you will learn how to write a C language program to control a 7 segment and also PIC 16F. And then the second one, also write a C language program. This time you need to write to control, you need to write a C program to control and manipulate a 7 segment and a keypad by using the same PIC 16F877A. And the equipment required will be these 4 items: MPLAB X IDE, the IDE software, and then we have the compiler AC8, and then computer, and then the last one, the simulator software, SimLab. So we look at the first introduction first. This one will be on 7 segment display. So I think no need for a very detailed explanation. You have learned this through our lecture week number 4. So basically, 7 segment is an indicator device, a component. So we use it to display number from 0 to 9. And sometimes we can also display a certain specific alphabet, but that one very limited capability from A up to D, up to E, and also F, the last one F. So we know that there are 2 types, CA, common anode, and then the last one, CC, common cathode. So the internal structure would be the same, but the connection, the source connection, and then the logic might be different according to the type of configuration. So the input, we have input from A up to G, only 7 bit. This one excluding the decimal point. Okay, so if you refer to figure 3.1, this one, okay. This one, when we decided to include an encoder or also a decoder, CD4511. So basically for your lab, if you want to, this one is optional, whether you want to directly connect the setting here. You want to connect the input pin from A to G to directly to the microcontroller, or you want to follow this kind of connection. So this one I will leave it to you. So you need to decide. However, if you decide to use this decoder, make sure that the software, SimLab here, contain this decoder. If the software did not contain this device, so you will need to directly connect the input to the microcontroller without the decoder. So basically, if you refer to table, this one table 3.1, table 3.1 here, okay, show the binary for displaying various numerical and also alphabet character for both common anode and also common cathode. So you can see here. So if you are using common cathode, make sure that the logic here must be high in order to display a certain segment on this device, on this instrument. If you are using common anode, the logic, active logic must be 0. Okay, so this one without the DP, yeah. So you can follow from here. So you can see, yeah, from numerical from 0 to 9, and then from alphabet A to F. So the arrangement for both formation are shown here. And then this one, if you are using PIC-SIMLab, make sure that the input here, starting from A up to G, connected to the output pin of microcontroller. So it is advisable that you use port D, to be easy. If you want to include CD, the decoder, so make sure that your connection is correct, and also that this decoder contain inside the PIC-SIMLab library. And then if you refer to figure 3.2, this is the truth table or the function table that you need to configure when you want to use this decoder CD4511. So make sure you follow the arrangement, high and low arrangement. This one no need, okay, because this one will give out the output. The two column here that you need to concentrate. But since, like I said, since we only want to show, want to display the number, so basically for this part, you no need to, it will be unnecessary for you to connect to the microcontroller. Better if you follow the diagram shown in the lecture note, we just connect to the either source or ground. Okay? That one, if you want to display this limited number. Okay? And then this one, you just connect to the microcontroller output pin. Okay? It can be anything, just as long as 4 bit. And then if you read here, considering the limited capability of the PIC-SIMLab, the feature is not available. So this one related to this one. Okay. So this one, when the statement was made, at that time, we investigate that the current, that the library is not available at that time. But right now, from my previous review, this feature already available, but only for newer version of PIC-SIMLab. So if you want, you can explore. Except that older version, the decoder is not available. So you can try to experiment, try to explore the newer version, whether try to investigate whether this decoder available or not. And this is the configuration, connection setting for common cathode and also common anode. I think this one no need for the explanation. So we go to section 3.0, keypad interfacing. So what you see here in figure 3.4 is actually the internal structure of the 4x4 metric keypad. So why 4x4? So you can refer in your model, I think the last page, second last page. Okay. So this is 4x4, 1, 2, 3, 4, then 1, 2, 3, 4. So there are 4x4 keypad. So this is what the keypad looks like. Okay. So basically, when we refer to this figure 3.4, it is actually consists of push button. Okay. So push button. So total push button is 16. So there are 16 push button. And then this push button is representing specific number or character on the keypad. So the user, when the user want to input something, so the user will key in according to the character that the user want to use, want to display. And then when the microcontroller, through special algorithm that we're going to explore later, the microcontroller will process the input and then produce an output that related to the input. So basically right now what you see here is a switch button. And then the other one is what we have here is a row. Okay, up to 4 row, and then this one column. So the arrangement, the switch button for one row contain up to 4 column. And then inside this column contain 4 switch button. And then read each respective column, respective row. Okay, so we have 4 rows, so each respective row, the next one, and the next one contain the same thing. 4 switch button, 4 push button, and then 4 column. Okay, so how does the program function? How does the keypad function? Okay, we refer to the figure 3.5 and also 3.6. Okay, so 3.5 and 3.6 will be the same, except for that for 3.6. This is how you connect, and it is advisable that you follow the setting here. Okay, so if you want, if you are if you are in A1 mode, you can use any port that you want desired. But for beginner level, for beginner mode, if you try to learn, okay, better use the setting shown here. Okay, whereby KC1, KC2, KC3, KC4 connected to RB4, RB5, RB6, and then the last one RB7. So the K here we connected to first half of the first byte. Okay, so, the second byte, the last half byte of the port B. So we know that port B contain 8 bit. So the last, this one is the first. So R1, so R stand for row, C stand for column. So R1, from R1 to R3, you connect to the first half of the port B. From bit 0 to bit 3. This one you connect to R1 to R4. And then the remaining KC1 to KC4, you connect to the other half of the port B. Okay, starting from port B4 up to port B7, this one you connect to C1, then up to C4. So that is the connection. You can also use, if you want, you can also use RD0, RD1, RD2, RD3, and then this one, you can also use RC0, RC1, RC2, RC3. Okay. Anything is possible, just as long as the connection, one pin for each of the connection. Okay. And then make sure that we are using the port here is free, not connected to other device. Okay, so for beginner, it is advisable that you follow the settings shown here. And then if you refer to figure 3.5, okay, so this is how you set. Previously, this is how you connect, and then this is how you set. So for the first half, first half byte, first half byte of port B, make sure that you set it as output. Okay, from RB0 to RB3, you set to output. How you set to output? Through trace B. So trace B0, trace B1, trace B3 must be set as output. Okay, and then the other one, RB4, RB5, 6, 7 must be set as input. So if you want to set the input, so trace B, since you are using the whole port B for column and also row, so the output must be first, must be set first, and then followed by the input. Okay, starting from B3, B0, B3, B0, B1, B2, B3, input, output, and then followed by B4, B5, B6, B7 as output. So this one should be 0, this one should be 1, indicating output and input. Do you have any question? Ada soalan? Okay, no question. So we move on. So this is how the section here will explain how does the program function, okay, when reading with the input shown here. So basically, the method used, we call it scanning method. Okay. We use scanning method to detect key press detection. So when you press certain switch, can be either switch, it can be both, it can be three, and so on. So that one you need to investigate. So let's say you are pressing a certain part of the switch. So the next process or process of before that, we call it scanning process. So the scanning process used to detect key press, okay, from the user. Okay, so what happened is that the program which the programmer will be writing is a process whereby it will scan column by column and row by row. Okay, so scanning means that the program will detect column by column and row by row. So how does this method is being executed? That one we will see later. So in the program, the row is set as output and the column as input. Okay, from port B, port B. The first, you can see from here the arrangement. Okay, this one set as output, this one set as input. And then the program will start by first scan. Okay, first scan, it will row one is clear. It will give out logic 0 to row 1 and column 1 to 4. So basically, starting from row 1, row 2, row 3, row 4, the program, after the programmer has finished writing the program, so the method will scan through each respective row, starting from row 1. The row 1 will be clear by logic 0, and then the rest, row 1, 0, row 2, row 3, row 4 is high. And then after that, row 1, 1, the 0 move to row 2, row 3 high, row 4 high. And then the order, the 0 move again to row 3, row 3, 0, row 4, 1, and so on. So the scanning will continuously rotate, looping in that particular order, starting from row 1, 0, the rest is 1, and then after that, the following row low, and then the rest is 1, and so on. Okay. So the low is moving each respective row. And then every time that particular row is 0 or low, so this means that row is active. So basically, the program will detect any key press from the connected pin here. Okay, so if row 1 is 0, so it will detect any key press. If if the user press here, so this means that the output here should be 0. If not 0, so it will give up high signal, and so on. So that is the working principle of the keypad. Okay. Once the key is pressed, the code will store that particular character, and then it will jump out from the scanning loop, and continue with the following action. Okay. And then the process continue to the following row, and the process repeated itself continuously. The process repeated continuously. So if you are having problem, I think this one should be, if you can be what this one, I just create this one edited version of keypad. How does the keypad function? try to view this one first, and then we go, after that we will go to the exercise number 1. Okay, you have some basic idea of the operation of this keypad. That's soalan lah. Okay, no question. So we move on to the next section. So if you're having problem, you can ask later. Okay, so you're referring to figure 3.7. Right now, we are going to look at 7 segment first. For exercise number 1, the connection is shown like this. Okay, the data pin starting from A up to G connected, okay, to the respective 7 segment, and then these 2 line arrow is the select digit. This one to select whether you are using the first segment or the second segment. And then the question, write the following sample program to count from 0 to 9 on the 7 segment. The counter will increment when switch 1 is pressed. So we have input and also we have output. Output connected to 7 segment. Input we have switch 1. So the program code here, okay, similar like the previous one. We define, we represent RB0 with switch 1, SW1, and then after that the rest we can call okay, without referring to RB0. So right now, SW1 is actually RB0. And then the other one, seg1 and then seg2, representing RB0, RB1. Okay, so we have 2 port, port B, also port E. Since we are using port E, make sure that you disable the analog input. Okay, so whenever you are using port E or port A, make sure that you include this port, okay, because it will disable the analog. And then, okay, this one you just copy. Okay. This one is a subroutine that will display a value of keypad on the 7 segment. Okay, so basically, if you are looking at this subroutine, so the name of this subroutine is S71. It's display BCD. So if you want, you can rename anything you want. But be sure that when you want to call, the name must be correct. And then this one, this is actually a function. It will return, it will receive value. So the value of the parameter here is unsigned char BCD num. So BCD num is the name of our variable. Char means that the range of BCD is from 0 to 255, and then it is a positive value. So all of this characteristic is for BCD num. And then it will do this routine. It will give out value from BCD num from binary pattern here. Okay, where does this come from? This array. From this array. Starting from 0, 1, 2, the index number 0, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. But the size is actually 10. Okay, but the index number, when you want to call it, you must start from 0. Okay, so this is the array. Array is actually, this is the name of our array, binary pattern, and then the size. Okay, the size leave empty. Okay, this one you can also use, or if you want, you can put the size, which is 10. Okay, if you want. And then the name is binary pattern, and then the size is char from 0 to 255, and then the value is only positive. Okay. So the type, the format shown here is hexadecimal. Okay. So from the channel, we see that most of the coding setting shown is in the form of binary. So this one is for hexadecimal. You can put any format you want, just as long as you know okay, what type of format you are using. So the array here, okay, the array here, the element, the data shown here is in the form of hexadecimal. Okay, so port D will give out pattern from here, okay, that refer to the input from here. So if the put shown here, if the number here is 1 to 0, 1, so the port D will give out value from here. Okay, so on from 0 to 9. Okay. And then we delay, wait for a while for delay around 30 microseconds. That one is a subroutine, okay, a function, a function. And then we will go to the main program. The main program, this one very compulsory. Okay. You need to follow the syntax shown there. Okay, you start with the setting of the port direction to trace D. Okay, we are using two port, trace D and also trace E and also trace B. Okay, B would be the switch, E would be the data pin here. Okay, data pin here, and then sorry, not data pin, the select. Okay, select pin here, and then the data pin here connected to port D. So it is actually 3 port. Okay, so port D must be set as output. Then E also must be set as output, but B must be set as input. So you can see here B0. So this means that your switch must be connected to bit B0. And then okay, this one, as I mentioned, disable since we are using port E. Disable the analog input picture. And then this one, set 1 equal to 1, set 2 equal to 0. So which means that from the 2 segment, we want to enable only one. Okay, so for this example, we want to enable the first segment, and then the other one, the second one, we just disable it, okay, by giving 0. And then this is the variable. Okay, we introduce another variable, we call it up, the range. Okay, the range, the initial value start from 0, and then the size, the size is char. So char from 0 to 255, unsigned. So positive value, positive value. So that positive value char means that from 0 to 255. Okay, why do we need to introduce variable up? Because here, okay, we want to increment. So why char? So because from 0 to 10 only. So the limit is 10. So better to use coding size that is equivalent to the limit. Okay. So since we want to store up to 10 counter value, so better we just put assign to char. If the value is higher than 255, 300, 400, we need to consider other than char, such as int or integer. So that one, we introduce a variable called up, and then the initial value of up set to 0. And then this is the continuous loop. Start by reading input from SW1. SW1 located at RB0. So double equals to compare. So switch 1 If switch 1 condition for switch 1 is true, it is 0. You press the button for switch 1, it will give 0 to RP0. So 0 will active the following code here inside this routine. Okay, so if condition is true, start by calling this function. So start by calling this function and then up. Okay, up right now is 0. So initial value is 0. So up should be 0. So S21 display BCD 0. So what is 0? 0, 1, 2, 3, 9. So 0 here. Okay. So what is the value of 3F? If you want, you can use calculator. Set to programmer. Okay. So what is 3F? Make sure that identify first hexa. So click hexa 3F. What is the decimal value? What is the binary value? Here. Okay. 0, 0, 1, 1, 1, 1, 1. So this means that A, B, C, A, B, C, D, E, F. Okay. G is not shown. So G, okay. So G here, G is not shown. So A, from A to F. So this means that character 0 or number 0. So this means that this is actually representing 0. So, and then after that, wait for 1 second, and then you increment the counter, and then you compare first. If condition is not true or false, you repeat this one until the condition becomes true. The value of up equal to 0, then you clear, you reset the variable up back to 0, and then you go repeat the whole process. So this one is quite easy. Okay. Do you have any question? Ada soalan nak tanya? Okay. So all have no question. Okay. All of you have no question. So very confident. So we look at the program side. Okay. So this one. Okay. This one, I think most of you don't have any problem. Make sure that you create new project first, and then do correct setting, and then check. Okay, that here must be fixed lab, and then the microcontroller of choice must be PIC 16F877A, and then the debugger must be XC8. Okay, so that will be the 3 important items that you need to have okay, within this MP lab. Okay, so basically this is the basic one. The clock must be 20 megahertz. Okay, make sure that the clock setting is correct. And then you declare this one just basically coming from the example program shown here. Okay, so after that will be the same. Okay, so the pattern here, and then this is the continuous looping. Okay. Do you have any question for this side? Ada soalan tak untuk bahagian ni? Okay, no question. So we go to the peak sim side. Okay, make sure go to module spare part. Okay, click module spare part, and then the spare part shown here. Okay, but this one already been created. Okay, if not created, it will look something like this. Okay, empty. Empty. Okay, so make sure that the setting is correct. The microcontroller choice is PIC 16F877A, clock 20 mega, debug. Button here is pressed, and then you go to, okay, you can either choose input or output, but right now our 7 segment is output, so make sure that you choose 7 segment. Okay. We have 2 options here, like I said, okay, decoder and without decoder. So right now we choose better. Advisable, you use the blank one. Okay. And then the input must be push button. Okay. The setting part, this one, make sure that the cursor mouse is located within the 7 segment area, working area. Right click, click properties, left click properties. Okay, so this one you need to set. Okay, segment A, this one starting from RD0, RD0, okay, RD0, and then the rest follow D0, RD1, RD2, and so on. Okay, so make sure that your setting like this. Okay, so from segment A to G, you connect to port D, starting with RD0 and then plus one RD6. Okay, 7 bit. 7 bit, 1, 2, 3, 4, 5, 6, 7, 7 bit. Okay, and then the remaining 1 bit must be unconnected. Okay, so for the decimal point, you can put as NC, not connected. And then D1, D2, D3, D4 would be the select pin for this 4 segment. Okay, so for D1, set it to RE0, D2 set it to RE1. This one, RE0, RE1. If you have another one, you can add RE2, RE3, and so on. And then if you are not using, so better you set it to ground. And then the configuration must be active high. Why active high? Because we are giving out high signal 1. So in order to active, make the 7 segment become active, the signal must be high. That one for 7 segment. And then for the switch, okay, also same thing. Only 1 bit, okay, which is the first one, RB0, okay, connected to RB0, and then the rest not connected. The configuration must be active low. So why? Because of the program. Okay, this one active low. Okay, so this one must be active low. If active high, this one must be 1. Okay, low. Okay. Do you have any question? So I think that is the setting. Okay, so ada soalan? Nak tanya? Okay, so if you have a question, start by building the project. Okay, build success. Build success, and then you can proceed to debug main. Debug main, and then the tab here, fixing will appear if you're doing this correctly. Okay, so run target, hop target, run target, then you can proceed to this one. Okay, so why nothing? Because you are not pressing anything. Okay, NC, nothing, because not connected, only RB0. Okay, first click become 0, second 1, 2, 3, and then the final up to 9. Okay, after 9, go back to 0, repeating again. So that one, so you can see here, we are selecting the first 7 segment. Okay, so you can play around with the code. Okay, if I want, I can also change this one, 0 to 1. Okay, you can see what happened. Make sure when you modify anything, you need to repeat. Start by repeat by building the program, and then if build success, you go to debug. Okay, wait until you see the fixing here appear. Fixing tab here. Okay. Okay, when appear, okay, run target, off target, you can. Okay, so what happened? Okay, on the second side. Okay, on the second side. So you can play around. If I want, I can also turn on both. Okay, PHCM is ready. So okay, so we are turning both. We are using both. Okay, why this one not light up? Okay, we are not connecting to any port. And also the program did not support for this 2 and 3. If you want to view, you need to include. Okay, so that one will conclude example for the first one. For example, you have any question you want to ask? Ada soalan nak tanya? Okay, no question. So we look at example number 2. This time we will introduce another feature, a little bit complex. The complexity is higher than push button. So we are using keypad shown here. Using keypad shown here, and then the keypad need to communicate with the microcontroller, and then the microcontroller will produce output to the 7 segment. So referring to figure 3.8, the basic keypad display program. So this is the setting of keypad display program to a 7 segment. Write the following sample program to read the key press and display its number on the 7 segment display. For example, if key number 5 is pressed, the digit number 5 will be displayed on the 7 segment shown here. Okay. So there are several assumptions being made, whereby if A, B, C, or D is pressed, the 7 segment will display the same input. So if 5, 7 segment will show 5. If 1 press, 7 segment will show 1. If A, output here also A. If D, output here also D. The program code, okay, so you can see here, we are using all the port, all the pin in port B to make sure that your port B is free. So because we want to use 1 byte from port B, whereby the first 4 bit will be set as output, and then we rename. We represent RB0 as KP for R1, KP R1. So make sure that when you write this, the name, when you want to call, the name also must be correct. The syntax also must be correct. So from RB0 to RB3, set this output, and then we rename. This one. Okay, this one is 4 row, R1, R2, R3, R4, set as output. And then the rest, the remaining 4 bit, we set it as input, okay, starting from RB4, RB5, RB6, RB7. So total up 8 bit. So cannot use anymore because all the port has been connected to the keypad. And then after that, okay, define a function. This one we introduce like similar like this one. We introduce a function, this one for keypad, and the function contains scanning process as described, whereby it will detect row by row from the respective column. It will detect from the respective column according to the row or according to the active row, okay, which given out by 0. Okay, so this one you just copy, okay, make sure that you copy correctly. Okay. So this one is the first, the first 4 code just for the first row. Okay. We are giving out, we are detect any key press from row 1. Okay, is here. Okay, we give out 0 here, and then we want to detect from column 1 to column 4. Any key we detect here, row 1 can detect, and then after that move on to the second row. So okay, and then the first row, okay, we detect from the 4 column which one is being pressed. Okay, if either 4, if either 4 being pressed, so from this four statement, one of the 4 statement will become true. Okay, if not pressed, then the whole statement will become false, and then move on to the second row. Okay, so you can see here the arrangement. Previously 0, but now 1, and then the following becomes 0, and then you repeat again. Okay, repeat again. So for the first row, we know that the number here, the number assigned is 1 to 4. And then for the second row, the number assigned is from 5 to 8. And then the last, okay, from 0, row 3, 9 to 12. And then this one, 16. Okay. So why not, so as you can see here, okay, as you can see here, this one, sorry, this one. So you can see here, okay, all the statement refer to numbering. Okay, so you can see here we have also alphabet. So alphabet and then certain special character. Okay, so you can see here, okay, 13, 14, 16, and so on. Okay, so that one will be processed later. Okay, so right now the output from each of these statement is being represented in the form of number. Okay, so that one just for scanning subroutine, scanning function. And then after that, you know, this one coming will cover the output part, read 0, and then read 1, similar like the previous one. And then this one will display output from the 7 segment, okay, input coming from the keypad. Okay, so this is the main subroutine. But make sure, okay, you repeat the whole process. Declare array first, array for the 7 segment, and then this one. Okay, so you can see here, we are using quotient, first 4 bit and then the second 4 bit. Okay. B0 to B3 as input. So that's why F0. Why F0? Okay, if you want, you can check. Okay, set to binary. Check first. First F0. F0. Refer to this one. So you can see. Okay. This one from RB0, RB2, RB3, RB4, 0. So this output. Then the following from 3 to 7 or uh, or 4, sorry, 4, 5, 6, 7. From 4 bit number 4 up to bit number 7, this one will become input. Okay, so we are using the same port, okay, but different setting. Okay, the first 4 bit set as output, and then the remaining 4 bit set as input. So that's why F0. Okay, F0. Okay, but you can also set as 0, 1, 1. So this means that the arrangement, you can also play around with the arrangement. This one, F0, you can also put 0F. Okay, also can, but make sure you know okay, where is the output, where is the input. Okay. If you want to make things easy, you just follow the default setting here. And then for 3D output, E also output. And then for E, make sure that you disable the analog. If you're using port E, make sure that you disable. You need to include this code, and then this one. Okay, so we send low signal to disable seg1. Okay, high signal to enable. So this means that we want to select from the two segment, we want to select only one. Okay, go to the continuous looping. So you can see here, okay, variable. Okay, KP num. So you need to declare first before you want to use. You need to declare first. So char unsigned. So unsigned positive. Char is positive. So from 0 to 255. Okay, so the keypad can only hold value from 0 to 255. Anything coming out from read keypad must be stored in KP num. Where is read keypad? keypad come from here. Okay, so that's why okay, you need to copy and then make sure that every coding must be correct. Okay, so any value from this function will be stored. Will be stored in kp_num. And then after that, so you can see from kp_num, if kp_num greater than 0, so this means that the value here is positive value. Positive value. So this means that if the keypad press, then the value is greater than 0. From 1 to 9, then A, B, C, D, E, F, so on. Okay, why positive? So you can see from here. Okay, the return number, return location number. Okay, location number 16 from here. Okay, the return number 16, not the alphabet. Okay, the return number. And then after that you just call the array. Okay, you call the array according to the value, the number, index number from kp_num. Okay, do you have any question? Ada soalan before we look at the simulation. Okay, so if you don't have any question, we look at this one. This one do the same thing. Okay, so this is the how do you want to build the circuit? Same. Okay, output must be 7 input must be keypad. Okay, this one. And then this one setting already shown, make sure that the setting correct. Okay, so this one okay. RB0 to RB3 okay, connected to row, RB4 to RB5 connected to column. Okay, so the first 4 bit from here to here output, and then from C1 to C4 set this as output. And then the pole type must be up, and then the type must be 4 by 4. Okay, so that's it. So we look at the programming aspect. So you need to copy the whole thing. Make sure that the clock frequency same. Okay, define, set as output, the first 4 bit, and then the remaining set as input, and then you put the function to read keypad. This is for scanning process, and then okay, so the rest will be the 7 segment. Okay, so do you have any question? No question. So no question. Okay, so make sure check first before you proceed to anything. Make sure that you always check. Okay, Fixing lab, AC8 compiler, and then the microcontroller. Yeah. Okay, so if you're happy with your setting, proceed to build the program. Okay, build success, and then proceed to debug. Okay, wait until PICSIM tab appear here. Okay, so build successful. Okay, so PICSIM Epic syntax already appear. Target, run target. Okay, so you can see nothing. You need to press 1, okay, 2, 3, okay, 6. See, this one cannot show okay, because very limited. Okay, 0. Something happened, need to restart. Okay, so you can see nothing. If you check again, terminating. So when this case happen, so you can see okay, better it is advisable that you restart the whole program. Okay, show you that you close first, then restart again. Okay, so if you want to play around, make sure that you stop debug first. Okay, so previously you can see here the second segment. So if you want to play around, maybe you can modify setting here. You can put here 1, you can put here 0. Okay, repeat the whole process. Build first, success, wait until success, and then go to debug. Okay, system appear. Okay, so you can see here the movement from here, from second to the first segment. So that one will conclude the exercise, laboratory exercise number 2. Do you have any question you want to ask? Okay, no question. So we move on to design question. So 3 parameter that you need to follow for design question. Write a C program to read the keypad key press and perform the following tasks. If odd number is pressed, display the value on the 7 segment. If you are pressing odd number 3, 5, 7, 9, and so on, any odd value, that particular value will be displayed on the 7 segment. If even number is pressed, 2, 4, 6, 8, and so on, turn off all segment on the 7 segment. So meaning that it will turn off. Any value will be turned off. And if other key is pressed, for example A or B and so on, the 7 segment display will come up from 0 to 9 on the 7 segment display. It's other than odd or even. So the microcontroller or the 7 segment will start displaying come up value from 0 to 9. Okay, so the report format similar like the previous one. So make sure that front page is included, team member, 2 person, maximum, briefing only related to the design question. Okay, design question and not the topic, which is input and output on the design. Okay, so your design question involve interfacing keypad and 7 segment, and then the task here. So make sure that you try to elaborate on the particular task. And then for methodology, you need to include schematic and flowchart. Must be in handwriting from 1 to 3, must be handwriting, and then the conclusion also need to be in handwriting. And then for 6, this one program copy from the MP Lab. Okay, program here. Okay. And then the result and discussion must include 3-minute duration of output only. Okay, no need to elaborate anything that is not related to the output. Okay, make sure that the duration is within 3 minutes. And then you need to register using the following link. Okay, so using the following link, upload your report. And make sure that in your report, you must also include the link for your video, just in case. Okay, so the submission date, due date is next week, 29 on Friday, or 29 of April on Friday. Okay, so make sure that you submit before or on that particular date. Okay, so do you have any question you want to ask? Ada soalan nak tanya?
Sir,
Ya.
yang appendix program tu, copy from MP Lab tu, handwriting ke letak gambar je?
Sekarang ni saya nak bagi freedom. Okay, freedom. Kalau tulis cantik, tulis dengan tangan lah. Okay, sebab apa tulis tangan, nampak ni. Dia ada apa ni? Dia ada semicolon. Dia ada ni. Jadi membiasakan diri lah. Okay. Biasakan nanti nak type ni. Kalau tak cantik, boleh copy paste. Itu saja. Lagi mudah saya nak baca untuk makin.
Okey, terima kasih sir.
Sama. Ada lagi soalan?